Hello friends, today we are going to understand about mechanical engineering along with the software engineering. So this video is dedicated for mechanical engineers. So what does the software does with the spanners? Where the spanners should be used? Why the software should along come with us? This is the question you might have it. So let us find the answer for this. So software. Let us take one example. In a multi-cylinder engine, let us assume each cylinder should produce equal power. Then what this mechanical component has to work and what the software has to do? This is a question. So let us have this target. Let us understand what is the limitation to achieve it and why the software is being used here. So we know that technology comes with a cost. So if you invest huge, then you get equal benefit out of it. So cost of machines will increase. If I want to use it, for example, if I want to have a higher precision or a tolerance component, then I have to use a costly machines. Then operating cost will increase. Might be it depends on the technology, material wastage and other things also will comes into picture. The time to machine also increase. Tolerance, of course, can be achieved with the cost. So everything is required now. So you need a cost, you need everything to do it. So without tolerance, the component, you cannot achieve equal power in the cylinder because I have to get a means components for an assembly of the engine. So now point number A, I can also bore it with a hand, then it will have higher tolerance. Slightly, I can manufacture few components with lathes, automated slightly. Then the cost of machines are slightly high. So the cost is slightly high on this perspective. So this can also be used, but still, if I want a higher level, then numerical control, where I can go closer to microns, I can achieve it in closer to microns, yes, in NC. So, but the costly machines should be affordable and the price of the component also will increase because of this investment. CNC machines, programs can do a job better. You can achieve for sure in microns, but the cost will be very high. Now, the important point is the software where you can see tolerance is high, but the cost is low. How it is possible? What is going to do it? Yeah, this is a question. So let us see what does it that in an engine. So you might have seen in lot of log books that different process has its own cost. So if I go on with a traditional or a non-traditional machining process, then the cost will keep on changing based on the requirement. If I want a high precise components, then I have to go for a costlier machining process. So this is not only a cost, also the time. If it is so precise, if you want to machine, then the time taken will be slightly high. So the production time also will be high. Just think about producing 1000 components per day, and I want to, it's a time is important factor. Yeah, lot many components are produced across the globe for make one engine. So hundreds of component has to be produced. Then another important is after 2 lakh kilometer running on the road, what happens to this component? Cost, time has been invested, but after 2 lakh kilometer, whether it can fulfill the same demand, let us see that. So as I mentioned, we choose number of machines, what is required. Sometimes we go to even powder metallurgy concepts at just more than machining, where just see that we achieve a repeatability in the tolerance and also close tolerance are achieved between the components. So the variations are low. So now I can achieve micron level tolerance. For example, here if I say 2 plus or minus 003 component D can be produced, but engine has a lot of components. So each component has its own tolerance, but on a 0.003 tolerance, this was achieved. But since we assemble at end after end of a component in the assembly process, overall tolerance, though by this machines maintain a strict tolerance, what happens is the tolerance will be 104 plus or minus 012. So all the 4 components added up 104, the tolerance of 003 into 4, so it becomes 0.012. So again, I lost that third decimal point of tolerance to 0.012. So the tolerance is again increased, though I invested high. So now I achieved a tolerance, slightly high precision, higher machining, fine, but still I have some tolerance because of all the stack up or lot many components are getting assembled. So still I have a tolerance. Yeah. So assume this engine is built like that, 4-liter engine, 200 HP is supposed to produce. So each cylinder is 1 liter, 50 HP it has to produce. Now I have achieved a tolerance, but slightly closer variations will be there between the engines. For example, because of this, each cylinder will produce its own power. Each cylinder will not have equal power. For example, mean power in all the 4 cylinders, 50 HP each. So whether engine volume variations controlled by software, it can say software cannot go and change the volume of the engine. This is very clear. it can only aid something, how the mechanical component software will go and increase the volume. For example, a slightly higher from 1 liter, for example, second cylinder has 0.9 liter because of a tolerance, 1.1 liter, 0.95 liter. It keeps on varying between the production tolerances based on that. So every day each engine will have different combinations. Assume here I cannot vary the engine volume because it's all mechanical components. Only thing is maybe I can slightly vary on a fuel so that if I'm producing lower power, I can inject slightly more only in that injector by fuel injection system. With this principle, we can try to increase or decrease power by each and every individual cylinders. So the tolerance was achieved there. So further tolerance will be achieved here, not by machining, but by varying the fuel by fuel injection systems with the control of software. So software is doing this job, not a mechanical. This cannot be achieved in mechanical. So such a concept is tedious because we don't know which cylinder, which tolerance will come into picture in the production volumes. So increase the volume, not possible. So increase the fueling. So you get a power. So each cylinder now will get equal power, which is a mean power. Yeah. So this is achieved. So software is helping here. So I have still more tolerance. I achieved a tighter tolerance so that engine coming closer to the mean delivery or mean values of each cylinder. But still, if you see, I mentioned about reducing cost. Why reducing cost? Because each component will be produced. For example, today I produce 100 vehicles. Tomorrow I may produce 150 vehicles. In a year, lakhs and lakhs of vehicles are produced. So I cannot keep on machining with a higher tolerance. So here, one-time software development. So it will be used for all the vehicles. One-time investment, but goes for lakhs of vehicles. So ultimately, I don't want to tune each vehicle or each tolerance with a software. One-time investment. So the cost will be low, but precision will be high. You can understand earlier graph why the cost has come down, but the precision has increased just because of this. The tolerance between injector to injector or a cylinder to cylinder is reduced by this fueling by the control of software. So what happens to 2 lakh kilometers? This is a good question. So component might have wear out after 2 lakh kilometers because we are using vehicle rough and tough on the road. This was used, and with this component, the tolerance or the bond and torque and other the performance degradation might happen. So injection system as sensor, this give a feedback. So when the tolerance increases, engine fluctuations will be high. This will be sensed by the sensor and sensed to a control unit. So the control system understands this. That is day by day the tolerance is increasing. So engine fluctuations are increasing. It will try to vary the fuel here still further. So after 2 lakh kilometers, it tries to see what happens and try to vary it. So end of a day, the fluctuation should come down drastically, maybe plus or minus 100 RPM between the cylinders now becomes plus or minus 2 or 3 RPMs. So engine becomes smoother, even though the component inside has worn out or performance degradation has happened or aging has happened, still my engine has better fluctuations or engine is still on a mean level. The tolerance is being compensated. So lot many parameters will be varied inside the engine. So these components will, this particular combustion will take care, or the variations in a combustions or a fueling or a power, all these things will be taken care. These were the parameters. If you see here, we are not going to 2 lakh kilometer covered vehicle to vary this in the software. It's all learning itself just by the feedback of the sensor. So this sensor is giving a feedback, automatically it's correcting. So the machine is learning. So mechanical components are learning. So there is algorithm from the softwares. These algorithms take care of this learning. So learning makes it happen into the mechanical components. And even though the machining has achieved some degree of tolerance, lifelong the software takes care of a tolerance even after worn and torn. So this is where happens after 2 lakh kilometers. Let us understand more in machine learning in future classes. Let us jump on. So today we learned few topics. These topics helpful will be there. I believe if somebody asks you what you know about software doing in a mechanical components, you can use these terms. This will be helpful in your career, I believe. So I also have idea to post lot many videos which will be helpful for you guys. This will be helpful. Yes, I believe it. So for that, please subscribe and share this video so you get the notifications, and also chat if you have any questions here. I can reply to you. Thank you.